Okay, lecture 13. Here are some terms you should know the definitions of. Name 3 scientists responsible for determining the structure of the atom. Name or describe experiments they used to discover part of the structure of the atom and give the dates that made their they made their discoveries. So we have the dates. Need the name of the experiment. Name the 3 scientists. So these are right out of the book. There are other people who were involved in determining the structure of the atom, but these are 3 very important scientists. So let's just put them in order, chronological order. So we have J.J. Thomson, and in 1897 he used the cathode ray tube to determine the that there were particles as part of those rays. So he discovered electrons. And the book goes into detail there, but you should know the name of the scientist, the experiment that he did, and what he discovered. And then we have Robert Millikan. And this is in 1909, so quite a while ago, and he used what is called the oil drop experiment. And again, the details can be found in the book, but you should know the name of the experiment. And he discovered mass and charge of the electron. So Thomson discovered that there were electrons, that they were negatively charged. But all he could find is the mass to charge ratio. He couldn't find either the mass or the charge, just the ratio of the two. And Robert Millikan came along and determined the mass and charge of subatomic particles back in 1909. Not too shabby. And then Ernest Rutherford in 1911, thereabouts. And these experiments took a long time, but this is generally when their discoveries came out. And he did what's called the gold foil experiment, though he used more than gold in his experiment. And he discovered nuclei. He discovered that there were tiny, massive kernels of matter at the center of the atom, rather than all the matter being spread out continuously or in space. That there's actually this kernel of mass. So these things that we take for granted, these 3 scientists determined. So you should know their names, the date that they came up with the discovery, and then the name of the experiment. All right, 2. What are the 3 subatomic particles that make up an atom? What are their charges? Describe the relative masses. Describe the structure of the atom using these particles. So we have the proton, the neutron, and the electron. And I should point out that we abbreviate them in this way: P with a superscript plus, N with a superscript 0, and E with a superscript minus sign. Their charges are +1, 0, and -1. Now that's just a relative charge. We also could do it by coulombs, a unit of charge, electric charge, but we'll just leave it like that. That's fine. As long as you know protons are positive, neutrons are neutral, and electrons are negative. And then the mass of the proton, so M for mass, and then we have a subscript with the symbol P+, is approximately the mass of the neutron. Neutrons are slightly heavier. And then the mass of the electron is approximately equal to the mass of a proton divided by 2,000. Or an electron is 1/2000th the mass of a proton and mass of a neutron. So again, we know what their exact masses are. Well, out to like 5 or 6 decimal places, but this is fine. You just need to know that the proton and neutron are very heavy compared to the electron, And what we find is that we have the last thing here to describe the structure. So we have the nucleus, and we have the protons and neutrons are present in the nucleus in differing amounts depending on the atom. And then we have on the outside, zipping around, we have the electrons. So we should know that basic structure. Now when we're trying to describe different isotopes, or different nuclides, another name for it, we use nuclide symbols. And a nuclide symbol, X, A, and Z. The X is the element symbol, or the atomic symbol. So this isn't the answer to the question, it's just to set it up so that we know what we're doing here. And then we have the atomic number is Z, and the atomic number is the number of protons. And then we have the mass number, which is A, and A is the number of protons plus the number of neutrons. So if we look at, they say, what is the nuclide symbol for the element with atomic number 67? So 67 will go on bottom, mass number 137, and then the atomic symbol, well, we have to go to the periodic table. I don't know what offhand, 67, and that's what the periodic table is for, so you don't have to remember all of these. This data was 67. Okay, holmium, here we are. There's some that you'll just come to know because you use them so much, but not holmium, not for many people. So that's why we have the periodic table. What is the nuclide symbol for an element with atomic number 32 and 33 neutrons? Now A, so this is Z, 32. A is going to be equal to Z plus, plus. Capital N is often used to represent the number of neutrons in this context. So we have 32 plus 33, so this is 65. And so that goes here, and then 32 germanium. Okay. And you can see these are just different ways of asking the same kinds of questions, just trying to find the nuclide symbol, but we can do it in a number of ways. Here's another one. What is the nuclide symbol for sodium? So we already know what this is. With 12 neutrons. Well, we need to know the atomic number. I know that offhand, but I'm going to double check. It's 11. It's one of the last ones that I know offhand. 1 through 12, 1 through 11 is usually what I can remember without consulting the periodic table. And then the the mass number is going to be 12 plus 11, so that's 23. So if you're given, usually there's three things that we're trying to find: the symbol, the atomic number, and the mass number. And if you're given any, if you're given enough information, you should be able to fill in any blanks, and that's how it'll normally be set up. Okay.